Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey there, guess what? You have found another episode of the Digital Enterprise Society podcast. Thank you so much for selecting this show and coming along on the journey that we have created that we mean to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas around the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor every single week to co-host this show with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig.
Hey, Thom. Good to hear your voice. I'm ready for my next round of battle.
I was going to say, today it's not just Craig. Today we also have Mark Pendergast, and he is the content trustee at the Digital Enterprise Society. And the two of them, every month or so, have a digital battle. And this is our fourth time. And today we are going to talk about Agile hardware development. Now, we know that there has been a huge revolution in the software world around Agile, but have those Agile methodologies been taken on by the hardware people yet? Well, should it even be taken on? Or is it just all hype? And that's what they're going to talk about today. So, welcome to the battle, Mark and Craig.
Well, it's good to be here, Thom. It's always fun to battle with Craig. We certainly have a history of doing it. And although we don't always battle to the death, we always raise a lot of good points and help people understand at least why this is an issue and where they might go to try and solve it.
All right.
Well, yeah, if we battled to the death, we wouldn't do this again. And I do want to do it again. So today's topic will be interesting. And I'm pretty sure we could argue either side, but we chose a side. So here we go. Let's hear the first question.
All right, let's get started with this. What does Agile hardware development actually even mean? Craig?
I have no idea. No, what I think is fast, iterative cycles with the customer. We talk a lot about it for software, but the same thing for hardware. So, when you use a product like a toothbrush, right? And the toothbrush just isn't comfortable, you want to quickly change the ergonomics of the toothbrush. Agile hardware development would be to do that with the customer always involved.
And Mark, what do you think?
Well, I agree with Craig's first point is I frankly can't even figure out what they're talking about a lot of the time. I mean, look at software development. They're talking like 2-week sprints and delivering viable, useful stuff every 2 weeks. And I'm going, hardware? I don't even know if you could chuck up a piece of steel and get the cutters going in 2 weeks. So, I mean, it's a mystery to me, but I understand Agile software development pretty well. And I see some of it as exciting. The customer focus, as Craig mentioned, the getting together to see whether things make sense on a regular basis makes sense. But hardware, it's easy to move electrons around. It's pretty hard to move atoms around. I mean, that's the whole basis of the digital revolution. And I struggle to see how this is different than the good old-fashioned prototype cycle, where you just got endless rounds of prototypes trying to figure out how to get the product to work. And they were really expensive. And we've put a lot of the effort in the digital enterprise to stop doing that. Yet we seem to be coming full circle again.
Well, but prototype cycles are expensive when they're only done in hardware that involves raw material like steel and so on, right? So the notion that this keeping the customer involved all the time is part of the notion of Agile. This other notion of Agile, really fast cycles, well, because software is just a different thing. It is capital intensive, but the capital is the human being, right? Mm-hmm. And so when they come up with these ways of sharing software libraries and all this other stuff, it makes you really fast, but it also creates cybersecurity issues. Anyways, the point about speed and customer involvement, there's parts of the car business, which, Mark and I had different roles in the car business, that were in fact very agile, meaning the customer was involved all the time. And especially this area of calibration where we did the final tuning of the car. That sure felt like hardware tuning. We would change a spring and a suspension, or we would change, maybe some bushings or some belt tensions. That's all hardware. That's not software. And we would do that pretty quickly. Now, we had to design a product, an architecture that would let us have that degree of freedom late in the game. And I think this is part of where the software guys get lost, because they don't remember they got to keep an architecture in mind. And if they break the architecture, their agility falls apart. So I think there are examples of agile hardware development, but I think when people hear those words together, they're thinking like Mark's example, oh, I want to build a chassis element this way today and this other way tomorrow. No, those tend to be over a quarter or longer because there's a lot of other stuff you have to move around. It is the physics of the problem, right? The moving material.
So this actually transitions to my next question actually perfectly, and that is, what is the advantage or disadvantage with agile hardware development over those standard multiple prototype cycles? Why would somebody look to even do it differently? Why would we look to agile?
Okay, well, I'll take a crack at this one. And I think agile, the prototype cycles had a tendency to take on a life of their own, and just were broken. And they became purposeless after a while. And I think agile is starting to bring some bigger frameworks in to keep things on track. But again, as Craig said, there's chunks of hardware. If you're doing a tractor, what's the minimum viable tractor that you're going to deliver in a couple of weeks? I mean, I don't know. What, you put a steering wheel on a tire and say, well, okay, that's the first iteration. The guy can sit on the wheel and bounce down the road. You know, I think that's kind of ridiculous. So I haven't convinced myself that part of it works. And then also in software, everybody's a generalist. When you decide you're going to deliver these 10 features, you got 10 guys, and they could probably each develop any of the features because it wouldn't matter. And you can have a small team focused, and whatever shows up on their plate, they're going to feel comfortable coding it, or at least, within the group, they got the skill. When you're talking about hardware, you're talking about system engineers, mechanical engineers, electronic engineers, wiring engineers, industrial engineers. You got all these people. Your Scrum team's going to be huge. It's going to be half a wing on a building. And how do your daily stand-up, they're going to have a megaphone to yell at the guys in the back of the room. And so I don't know how it scales into the level of detail that you have to get hardware out the door.
That's a really good point, the scale of the team. I have a bitter memory of a mostly software and calibration teams that were too big, and despite they were following Agile, missed some really key things, and we ended up with a product recall. That's probably a history lesson that shouldn't become public, but it was interesting. It wasn't hardware that had the problem; it was software, and it was the team size. It's a good thing you point that out. So maybe an essential point about Agile is it is designed for small teams, and to my point about architecture, and it's really not designed for architecture. You need architecture. You need to know, are we doing a 4-wheel car or a 2-wheel motorcycle, and then within that architecture you can decide what goes fast and back to why Agile at all. It's got its own name now and all this, but if you go back to those guys in the mid 1990s that did the software manifesto, the main point they made, and they were absolutely right, is most of the requirements we write down for systems and software elements are really just wishes. They're not really requirements. Whereas in hardware, maybe because we have 150, 300 years of experience, when we say make the bore of the cannon this precise, we mean that because we know from experience that there only so much gas can escape around the cannonball before it doesn't work anymore, right? So I think we have this notion of specifying details, and in software, at least, a lot of times we're not that good. We don't really know the requirements that well. I might suggest to you it's just a maturity of the discipline. Those other disciplines that Mark mentioned, they've been around for over 100 years, in some cases thousands of years, right? You can't say that about software. It's been around in our lifetime, but it wasn't here other than a few mathematicians before 1950. It wasn't. So maybe it's just a discipline? I mean, what do you think, Mark? Is it just a matter of getting better at it, getting more mature? We need 5 generations? What do you think?
I think that's part of it. I think the other thing is software is less constrained than hardware. Software can be anything.
Oh, hooey.
And
software. Okay, maybe. Go ahead. I'll let you finish. But it's unconstrained. It has to fit in the You're not that young. We used to run out of memory and throughput in the bloody controllers because software was too expensive. But I digress.
We'll just pump it all.
It's just gone now. That's true. It's all cheap. Yeah. Put it in the cloud.
So, okay. But no, I think that's it. I think also you had a great point, Craig, early on. As when you're doing hardware, you got a contract. You got a ship date. The software guys can be a little loosey-goosey and come in with 90% and fake it. But the hardware guys, you can't go with 3 wheels, right? You can't leave off the steering wheel or anything.
Oh, by the way, if you fake it at 90%, you're about 10% done. So you're in real trouble. The sooner you admit to management you're in real trouble, the better off you are. But
yeah, well, it's hard. It's easier to get partial functionality in software than it is in hardware.
So it appears to me then that software, because it's hard to see, it's true, it's hard to see, right? Mm-hmm. When you're talking outside of the software community, management, customers even, they don't really understand. And I'm not sure they should understand, by the way, but they can be fooled. And what's really scary is when the software engineers themselves or the Scrum Master is fooled. That's a problem, and it happens, by the way. And so I don't know. This point about requirements goodness or the requirements can be built. This is part of the problem. And then my story about Agile for hardware that convinced me is I'm a space nut. I'm an aerospace engineer by training. Apollo 13 is an excellent example of Agile hardware development. Our guys are up there. They're on the way to the bloody moon. The darn oxygen tank explodes. They're going to run out of guys, you just got this box of parts. These are the only parts available. Figure out a way to get them back here. Got to last for whatever it was, 3 days, so they can flip around the moon and come back. So that was Agile hardware development. So what did you know? You had the clear requirement of duration. You had the clear requirement of these are the only parts you have. And so all of a sudden you got really creative people. They probably had a Scrum Master. We got 1 hour to go. You can just imagine every hour he was having a meeting about, okay, now what did we learn now? And how can we do this, right? How can we clean the air? How can we, keep the temperature livable? And so I think the thing that I would take away from Agile practices and that lesson is the sense of urgency. There's a deadline. And by golly, you're going to meet it, and we're going to make progress, and we're going to be able to measure the progress. Those are the essence things of Agile. Well, for the record, that should apply to hardware as well as it does to software. That's a good way to manage an organization. What do you think?
Yeah, well, and I'm going to maybe take us another step forward and look at, what are some things that do apply? Because I can see good in Agile for hardware. And to me, the big thing that fails in waterfall is you don't know you've failed until it's too late. Yeah, and I think, 3 years later, you're going, I thought you were doing this one. No, I thought you were going to fit in that space. And so I think the idea of like the daily stand-up or the, every 2 weeks come together and at least talk about what trade-offs you've made. Because, Craig, you know this. There are a million trade-offs made, and the guy making the trade-off, that skilled professional with 100 years of lineage, doesn't know what the guy next to him just traded off to contradict it. So I think in the digital enterprise also, we're arguing about the old days, the traditional enterprise. In the digital enterprise, imagine Agile in the virtual world, in the digital thread. So now you say, you got to have your CAD model done in 2 weeks, and we're assembling the car in 2 weeks, as good as you've got, and we're going to review that car virtually and decide who made bad trade-offs and send you back to the drawing board, not in 2 years, in 2 weeks. And then 2 weeks after that, you come back together and again and say, oh, my goodness, what did you do? And, oh, by the way, we just ran a simulation, and there's no way that strut's going to work.
Right.
So in the virtual world, in the digital enterprise, all of a sudden Agile hardware starts to really take on the same power as software because you're shoving electrons around.
Yeah, well, and that's electrons are free. Well, mostly free. They cost energy to move them, by the way. But so this is a really good point. The more we do our hardware designs in digital tools, what we talk about here at the Digital Enterprise Society, and the simulation and the load cases and all the databases from all the machine learning, the more we do that in the digital world, the more time is no longer measured by the wristwatch, right? Rather, it's measured by how fast we can do a cycle. Well, computers, the only thing limiting us is more computers. And we've been talking about how there's more and more computers thanks to cloud-based services and everything else. So maybe that's the trick. Agile hardware development, those early development cycles, when they're done in simulation and computer-aided tools, design tools, manufacturing tools, and so on, now all of a sudden, the prototype cycle can be a couple days and a week. It doesn't have to be a quarter, right? And it doesn't need the outlay of machinery, though there is the outlay of computers, which is not near as expensive, but still not free, right? So I like this
more
point.
Flexible.
Yeah, and if the cycle time has gotten similar to the cycle time of software agile development, well, then I would think these two teams should be able to work well together. They still need an architecture, but I think it should work well. So a recent problem in the supply chain for cars has been the lack of chips or specific chips from the foundries, right? For lots of reasons, which we don't have time to talk about. But can you imagine, like Apollo 13, okay, guys, we got to change the controller inside the pickup truck because that chip's not available, but this other one is. And it's not as capable as what we wanted, but it's as good as it was 3 years ago. Can you make the product sellable with that 3-year-old technology? And if so, that's a form of agile hardware development. We changed to constraint, electronic hardware in this case. We changed to constraint, and now we're going to try to make it work with the product, right? By the way, they didn't have time. They only had a few weeks to figure that out because you shut down the line otherwise, right? So constraints, I think, drive Agile. They may be what really drives Agile hardware development, and they'll drive it because it's cost effective, like, those guys that watch the money.
So this is a really good transition into my next question, and that is, what are the steps that now need to be taken so that they can become more or become really Agile in hardware development? What steps should be put in, Mark?
Well, I think we talked about some of them. I think the digital enterprise, that vision is probably your first step, is to consciously say, this is where I want to go. And I think we had a podcast a while back where we talked to the Department of Defense. And their first step was, let's write down the strategy. We don't know how we're going to do it. We don't know what it's going to look like when we're done, but at least we're going to commit that we're going to be digital. We're going to be Agile. And I think that's step one, is deciding you want to be there. I think all the digital tools, implementing those, being as realistic as possible, getting the simulations. Again, simulations are useless unless you can validate them. So you got to know what your constraints on the simulation are. And then I think the traditional siloed hardware organization has to be blown up. Software was able to do this because they didn't have 100 years of lineage behind them. Hardware has 100 years of lineage that we do not talk to each other. We are in our silo. We know better than these guys down the hall. They're always screwing us up. And it needs to become a team concept. And it needs to be a team game like football or baseball, where you're all on the same team. You're shooting for the same thing. You're contributing what you can, but you're looking at that end goal of getting to customer satisfaction, not making your discipline look like the other ones are idiots.
I would add to that, hardware prototype cycles are becoming dinosaurs. They really are. And if you're driving your company today on a hardware development cycle for prototyping, now I'm just talking about the prototype, first, decouple it, get it off of your main path for your product. And second, you still have to do it, fine, go do it somewhere independent, like a university or a different department. And then the second thing is, absolutely, when you learn what it's about, simulate it, because all this technology's here. The leaders in product development, doesn't matter what product we're talking about, all do simulation to replace physical prototypes. Remember, prototypes are useful to find what you don't know. But once you understand what you know, then the only reason to build a hardware prototype is to find the unknown. And the more you, like a car business, right? What's the unknown now? Well, the unknown's the battery stuff, right? We're learning pretty quick, but we're still having failures. But other than that unknown, there aren't many unknowns. And so you would expect nothing to be done with physical prototypes. I still remember when Mark, when I came back to Indiana, this one guy, I saw we had all this modern simulation stuff there in Kokomo. And I'm like, well, this is really cool. I thought I would be taking a step backwards. I'm not. And the guy I was arguing with said, why would I do that when I could go build one? And I'm like, well, how do you build it? Well, they build it in the shop. Well, that's a hand-built, one-of-a-kind, great thing. Okay, so it told you some of the physics, but it didn't tell you how the mass-produced vehicle is going to work, because that's a different set of variations. So my point is, get the unknowns off the table, decouple them, and then you can do agile hardware development, because you'll have an architecture and you can stay within the constraints. So whether you're changing shocks or springs or belts, you'll be able to do things really fast.
Yeah, I think the other one that I read here recently is, if you're going to build hardware, build the minimum you can to test that unknown, and then move on. In fact, one thing that really struck me as amazing is I was walking through the plant one day and I saw something that just made no sense to me at all until I figured it out. They were trying to set up a new assembly line, and you got to have the ergonomics and how are people moving things and whatever, and it takes a lot of thought in how to do that. And they had gone out to the hardware store and bought big panels of foam insulation. And they had cut those down and mocked up the equipment, mocked up the hardware as a prototype, and had the operators going through the motions. Yeah. Now, they didn't mock up real hardware and real machines, whatever, but they had an unknown in how was the operator motion going to deal with this piece of gear. And they would cut a piece and they didn't like it, so they'd throw it away and cut another one. And again, they were doing a hardware prototype, but they weren't prototyping the real thing. They were looking at just that aspect of it that they didn't know.
Yeah, and it's interesting. They went and got something they could make in real time, because it was foam, as opposed to a bunch of stuff that had to be durable. Now, durable is important later when you get to rate, but at the beginning, it's not important. And today, that's a great example, because that can all be done in simulation. Whether it's Jack from our friends at Siemens or it's other tools, you can figure that stuff all out now in a cartoon at your desktop in your remote work locations, since you're not allowed to go to the plant right now. But
you got to remember, Craig, the customer is that operator, and they're not
exactly.
Jack, and they're not whatever. That's why they wanted something touch that they could touch. And I think that's where additive manufacturing is starting to come in, is you can prototype that part very quickly in plastic. Even though it's not going to work under the hood in plastic, you can at least touch it and say, okay, because not everybody can conceptualize. There's some guys I know that if it's in their head, it's just the same as reality. But I'm one of those guys, if I can touch one, my insights grow exponentially. So
that's Thom, you asked, what are the steps to Agile? Something like additive manufacturing as opposed to subtractive manufacturing. So additive is printing up a part, and you can see it within a few hours, maybe a day if it's a big part, right? Whereas subtractive, you got to build all this machinery that drills and grinds and maybe you melt and bend, and it's just more complicated. So additive, while it is hard to understand the technology if you haven't gotten into it, if you had it, you can get your prototype pretty quickly. So there's agile development, absolutely fast, customer involved.
All right, guys, as we wrap up our fourth digital battle here on the Digital Enterprise Society podcast, my last question is: agile hardware development, is it all hype, or does it solve a real problem?
It solves the real problem. The time to market, being flexible in a pandemic. What other lesson would you need right now? So it's absolutely going to happen. Additive is going to help it, additive manufacturing. And those guys that are stuck in those silos that Mark did a good job summarizing, wake up and get out of your silo. Yes, it's work to learn the other guy's job, but you better start figuring it out. How about you? What do you think, Mark?
Well, I think there's still a lot of hype in it because we haven't figured it out yet. And I think we've got the toolkit, we've got the erector set, but the end-to-end process is still kind of right on the tip of our tongue and not quite there yet. But I don't know what agile hardware development is going to look like when it's done. It's probably 10 to 15 years behind software. But I see, as you said, you see pieces of it emerging, and you see people being successful doing that. And there's nothing like having people be successful to to have something move forward. So I think there's a lot of hype in it right now that just, just plunk in your software system and it'll work. And I don't believe that's the answer. I think it's taking the toolbox and using it differently.
Yeah, you reminded me of one other thing. There's a gentleman, researcher, I think, at Carnegie Mellon, and I did guest to an Agile software conference. And he ended his keynote with this warning that, it's great that we're fast and we can quickly iterate and all this other stuff, but cathedrals fall down when you build them incrementally. And his point was that architecture really matters. And so I think where the two worlds could help each other, hardware and software, is this notion of, well, Agile's great and being flexible is great up to a point. And the point is the interfaces in the architecture. And architecture is important. He encouraged people listening just to go spend some energy understanding the importance of architecture in the context of faster product cycles. The Apple guys are still building a device that fits in your hand, and it has evolved over several generations. Cars are the same way, right? The underlying architecture is the same, largely speaking. It has to fit in your hand. It has a couple key buttons. You got to be able to see it. In the case of a car, you got to be able to drive it, and it has to be safe. So architecture matters, and I think sometimes Agile just ignores it, which they shouldn't. Both Agile, any Agile. So let's have a discussion someday about architecture versus Agile. Okay.
Okay, that'll be number 5.
There you go. Well,
I'm not ready yet.
Well, Mark and Craig, thank you so much. I think these digital battles that we do are so informative for the listeners because they get to hear sort of two different viewpoints, but you're not so disagreeing that it confuses everybody. I think every time we do these, you help our audience get very clear on the subject at hand. Do either of you or both of you have a last comment about Agile when it comes to hardware? Mark?
I'd say it's coming. It's not quite here yet, but you need to get on the boat. You need to get out of your silo and start figuring out how to, get in bed with your customer on a regular basis, and then also get your teams together on a regular basis so that they're clear where they are and that they guarantee everything fits together and you're all on the same page. Those are the trends that are going to take us forward with this.
Craig?
And the pandemic just made it faster. The challenge is, how do you do all that remotely? But there are companies out there figuring it out. They are. So stay tuned. Those of you that join the party, you'll be successful. Those that don't, well, like so many of you, you'll just be unsuccessful.
All right. Well, we'll end it there. Thank you so much to both of you for coming in and being part of the digital battle. And thanks to everybody who tuned in and listened. Do us a favor. Join in every single week on the conversations that we have right here on the Digital Enterprise Society podcast, because every week we're going to bring you more thoughts, ideas, and information in and around product lifecycle management. And remember, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.